Like any vehicle, EVs are not immune to natural disasters, such as flooding. Understanding the unique challenges that a flooded electric vehicle presents is vital for a technician. When an EV is submerged in water, it introduces several complexities that differ significantly from those of traditional gas-powered vehicles. One of the most significant dangers is the potential for electrical shorts. Water is a conductor of electricity, and if it enters the system, it can cause short circuits, leading to fires or severe electrical damage. Thermal runaway is a critical concern when dealing with flooded electric vehicles. This phenomenon occurs when a battery cell fails, causing it to overheat and potentially ignite. The risk of thermal runaway increases significantly when high voltage batteries are exposed to water, especially if the integrity of the battery casing is compromised. Understanding the warning signs of thermal runaway is essential for preventing catastrophic failure. These signs may include an unusual increase in battery temperature, swelling of the battery casing, or the emission of smoke or unusual odors. The batteries on an EV are designed to be waterproof under normal conditions, but extended exposure to water, especially salt water, can compromise their integrity. Salt water presents a unique challenge for electric vehicles due to its corrosive nature. When salt water infiltrates an EV battery, it accelerates the corrosion process, particularly in metal components. According to the National Highway Traffic Safety Administration, Hurricane Ian in 2022 impacted between 3,000 to 5,000 EVs to various degrees. 600 EVs were a total loss, and 36 EVs caught on fire. In several instances, the fire erupted while the impacted EVs were being towed on their flatbed trailers. Ensuring safety when handling flooded electric vehicles is paramount. The first precaution is to avoid any contact with the vehicle until it is verified as safe. The vehicle should be parked at least 50 feet from the shop until a trained technician deems it safe to be moved. The risk of electric shock is significant, particularly if the high voltage batteries have been compromised. Wearing protective gear such as rubber gloves and insulated tools is non-negotiable when working on these vehicles. Next, it is crucial to de-energize the vehicle before any inspection or repair work begins. This involves disconnecting the high voltage batteries to prevent any accidental activation of the electrical systems. The first step in de-energizing is to consult the vehicle service manual. Each manufacturer may have specific procedures for safely disconnecting the battery. Using the right tools and equipment is another critical aspect of this process. Proper de-energizing techniques should be a part of every technician's skill set, as it is a vital step in ensuring the safe handling of the vehicle. Additionally, setting up a secure work area is essential. This includes having a dedicated space for handling potentially hazardous materials and ensuring that all staff are aware of the safety protocols. Once the vehicle is safely de-energized, the next step is to assess the extent of the damage. This involves a thorough inspection of both the exterior and interior components. Starting with a visual inspection can help find obvious signs of damage, such as coolant lines, corrosion, or damaged seals. Next, a more detailed inspection of the electrical system is necessary. This includes checking the integrity of the high voltage batteries, electrical connectors, and wiring harnesses. Utilizing diagnostic tools can help find any hidden issues that may not be apparent during a visual inspection. Handling flooded electric vehicles requires a comprehensive understanding of the risks and challenges involved. By prioritizing safety precautions, such as de-energizing high voltage batteries and conducting thorough inspections, we can ensure that the repair process is both safe and effective.